physiology, right? Renal physiology. Okay, let me first have an idea. What is your take on renal physiology? What are we exactly dealing with? Yes? Come on, speak up. Processes?
Processes where we excrete bodily fluids.
Okay, you excrete bodily fluids.
Yeah.
Okay, so principally, are you talking about just excretion?
Not only that.
Okay.
As well.
Okay, okay.
Yeah.
Any more answers? Any more answers? Endocrine functions, wonderful. Endocrine functions. Then?
Basically regulate the homeostasis of the body.
Excellent. Homeostasis, endocrinal functions, excretion. Then? Yes? Tubular reabsorption. Wow. Okay. Yes. Then? Have you gone through the module already? It was shared to you. Very good. Very good. That's a wonderful way to begin. And that is the reason Prof. Hafiz shared the module with you. So you come with an idea, right? So basically, now you can go to the overview, right? It plays a very important role. The urinary system plays a very important role in homeostasis. It has various other functions. Do you accept that there are chemical reactions in the body?
Yes.
Yes, right. Now these chemical reactions have byproducts too, right? Now this will have to be managed. Do you think the renal system plays an important role in that?
Yes.
Can you tell me? Looks like you already know so many things. So encouraging, as a teacher for me. Tell me, what is your take on that? Can you say just one thing, just one aspect of that? Okay, byproducts of metabolism handled by the kidney. Then, yes, then, what else? pH? What is it called? Wow, wow. Acid-base balance, okay, and so on. Right. Now, what are the three basic processes that you know of? You would have learned in school also, at least an outline. What are the three basic processes that are happening in the kidney? Pardon? Secretion. Secretion, excretion. Which comes first? Very good, very good. Which comes first? Filtration, followed by? Reabsorption, followed by? Then? And then? Yes, you just said. You just said. You were right. Ah, right. Okay. So look, can someone just read the overview? Yes, one person. Yes, Kribashini, come on.
The urinary system plays an important role, a very important and diversified role in homeostasis. The blood is circulated through the kidney where glomerular filtration, tubular reabsorption, and tubular secretion take place in order to clear the blood of unwanted or excess chemical substances. Subsequently, maintaining blood.
Yes, can you stop there? Subsequently maintaining, yes, blood volume, then blood osmolarity. What do we mean by osmolarity? What do we mean? Concentration? Yes. Okay, then followed by electrolyte balance. When we say electrolyte balance, what are we talking about? Sodium? Yes, yes, yes. Wow, okay. So now you know that kidney has certain functions, of which the most important the first point that you will have to mention is what? Regulation of? Yes, homeostasis. Then the basic three processes that ultimately lead to the regulation of your blood volume. Then yes. Okay. So you now know what are the main processes that are happening in the kidney, what is the purpose of the kidney, and what it regulates. Now, how does it bring about all this? Okay. So in order to understand how the kidney, you now know the functions of the kidney, and in order to understand how it performs the functions, what are you supposed to know first? Anatomy, the architecture of the kidney, right? The architecture of the kidney. And as you read, we will go into depths of each of these aspects and actually see, right, how every step is brought about, right? So for this, unless you have a deep knowledge, right, a concrete knowledge of the functional anatomy of the kidney, now I'm talking about, number one is the gross anatomy, right? Number one, then you look at cut sections, right? Then you magnify each portion to see the histological structure. This is the usual format that we have done with earlier, right? So there is no way, yes, please come, please come. So there is no way, take your seat. There is no way that you understand physiology without doing functional anatomy. And remember, your physiology overlaps. I've already told you that physiology overlaps with the other subjects, right? So here are the references. Here is a list of references. And let me test, what kind of knowledge do you need for this? That is stated as background knowledge. What priming have you got from the previous classes or modules that you have gone through? It beautifully gives you a background. I needn't have to insist how well the contents are arranged in this module with explanatory pictures, right? So what is the background knowledge that you have come with? Yes? General anatomy. Okay. Then other body systems. Very good. There's a huge overlap here because subsequently when you're doing the other modules, you will understand, right? The other systems. Then what was the first point that we spoke about? Homeostasis. Homeostasis. Remember, ultimately, all the organ systems are striving towards homeostasis to keep us functioning normally. Got this? So they all work in unison. They have specific functions. They have anatomical structures which have a beautiful architecture to subserve that function, right? And without that anatomical architecture, without that particular design, it is impossible for us to even go towards the functions. Got it? Yes. Yes, dear.
Are you sharing the screen here now? Because some of them are saying you're not sharing.
Wait, yeah. I hope you kept your modules open. A moment. Now? Now?
Yeah.
Okay, we are at the learning outcomes, right? We are at the learning outcomes. Can one of you all read? Yes, one outcome each. Mariam, can you begin?
What is the central concern of this module?
Yes.
And on the completion of the module, you should be able to first explain the role of the urinary system in relation to homeostasis.
Done, right? So you got it. So what is our first learning outcome? Explain the role of urinary system in relation to homeostasis. Remember, achieving homeostasis is by the processes that you saw and what they regulate, how they bring about is what you will be learning in the subsequent modules. Yes, dear, can you read the second learning outcome? Yes.
Using diagram, describe the anatomy and physiology of the kidney, including its blood supply and irrigation.
Got it? I told you functional anatomy, right? Indispensable to learn the physiology. Yes, someone online, could you please read the third outcome? Yes, students, please. Yes, Gaurav? Yes.
Briefly describe the general functions of the kidney.
General functions of the kidney, right? You have already enumerated few. We will read further, right? We categorize the functions of the kidney and we will see how it does, right? You will beautifully understand the interplay, right, and the interplay of other systems and the multivarious functions of the kidney by itself. The fourth outcome, please. Yes, someone online, please. Please participate in the class.
Describe how the kidney is related to body fluid and its content.
Describe how the kidney is related to body fluid and its content. Have you an outline of the body fluid? We've already touched that, right? In which section? In which part? In which block? CBS? Even before that? We have done general physiology. Who said that? General physiology, we did, right? So now you will learn more about it. Very good. Okay, the fifth one. The fifth outcome, onliners, please.
Briefly explain the three basic renal processes.
What are the three basic things? Yeah. Yes. You just have to briefly explain, and subsequent modules you will have in-depth classes on it, right? And discuss the basic principles of renal pathology. It's not enough if you know just the physiology. You will have to do the applied physiology part. So even in the introduction, you will see the basic principles. We are not asking you for in-depth knowledge of it, okay? So in physiology, you will get more information on the basic principles that are operational. And you can see in your module, there are objectives from the American Physiological Society for comparison, right? And then now we will be dealing with the significance and the scope of urinary system physiology, right? So what do you think is the significance here? What do you think? Come on, let's discuss. Let's discuss. See, it's a two-way class, right? It will not be a didactic lecture, no sage on stage kind of thing. It'll be a two-way class. Come on, tell me. There are portions which you will deal yourself, right? There are portions that you will be dealing with by yourself. So I wouldn't be going in depth in those portions. I will clearly tell you where you have to go that extra length to read. And if you have already gone through the module, you will see a simple questions. Try answering those questions, right? It reinforces, see, you will go explore for the answer. And when you explore for the answer, you will remember it very well. It's such a beautiful workbook kind of thing, right? Don't just, once you start, getting involved with the book, with the module itself, you will literally hear Prof. Hamdan speaking to you. That's the beauty of any book. It happens. Unless you celebrate the book is not going to celebrate you. Celebrate physiology, you will love it. Treat it like a festival. Are you going to come back to physiology classes? once you are done, once you go progress to the other years. So use your, see, you will be reading, but in an interactive session like this, right? Okay, come, let's start discussing. Okay, what do you think is the first? Let us talk about the significance. Yes, can I have your answer, onliners? Are you listening to me? Are you listening to me? We will try doing
Yes,
first.
doctor.
Yes, Kanna, tell me, what do you think is the significance of physiology? Yes.
Is it to maintain
Unit.
homeostasis?
Pardon? Pardon?
Maintain homeostasis. I think that's the most significant function.
Why should homeostasis be maintained?
It's
Why?
to maintain a relatively stable internal environment for all of the chemical processes to take place.
Okay, that is in case of, okay, in day-to-day life. Can you throw some more light on it? In day-to-day life. Yes, I can have volunteers from here also. In day-to-day life. Why do you think? Is your kidney functioning now? Yeah. What is it exactly doing? Micturition. Why micturition?
Excrete unwanted.
Okay, that is one. Otherwise, why should you micturate? Just excretion of unwanted substances? Pardon?
Maintaining the body fluid.
Maintenance of body fluids, yes. Then?
Electrolyte balance.
Balance, that's the word I wanted, right? Excretion is there, accepted. Whatever you said is accepted. Balance. When you are talking about homeostasis, it is a balance by all the systems that are operational in your body. Okay, and in this system, we are going to see in detail in the later modules how the kidney brings about that. How the kidney brings about that. Why one portion is permeable to water? Why the other isn't? Why are there pumps? Yes, one at the apical surface, one at the basolateral membrane. Why is there a difference? Why is there diffusion? Why is there an antiporter system or symporter system? Basically for balance. Basically for balance, right? So as you scroll down, okay, now tell me, is there an interplay of the other systems? Yes, because next we are going to a small question answer session, right? Let us make it interesting. Can somebody tell me about the interplay of the other systems? See, unless you really understand the interplay of other systems, when there is a renal pathology, it is not that only the kidney is affected. As doctors, you all must understand the interplay, right, as medicos. Otherwise, you wouldn't be able to explain why the other systems are affected. Can you name a few systems that have an interplay with our urinary system? Endocrine? Cardiovascular system, yes. GIT, then? Respiratory. Okay, shall we go just a step up? How is it working along with your respiratory system? How is it working? Just scroll your screen. We are in an activity. Do you see that? Involvement of organ systems in homeostasis. Look at that beautiful, beautiful picture there. Look at, yes, dear. Loudly. Acid-base balance. And you are talking about acid and base. Where do they come from?
From the, for example,
Yes. Hydrogen and bicarb. Yes. Where does it come from?
carbon dioxide and
Respiratory gases are involved. Okay, okay. Basically, where are they from? The cells, yes. What's happening in the cells? Chemical reactions. And what are these ions that Mariam was talking about? Byproducts, right? Byproducts. Now tell me about GIT. Tell me about GIT. How is GIT involved or plays along with your urinary system? Yes?
Maintenance of uric acid levels.
Maintenance of uric acid levels.
To avoid the accumulation because of macronutrient as well.
In your GIT. Then
The injection of carbohydrate, the proteins, everything.
ingestion, okay.
Breakdowns and those that are excess
Mhm.
in the body
Mhm.
eventually will be excreted through these kidney.
Okay, okay. Yes. What is the other important system? What is the other important system? How? How?
Blood volume.
Blood volume. How does kidney work along with your cardiovascular system to maintain the blood volume? Is there a specific mechanism in your renal system?
Yes.
Should there be?
Yes.
Right? If you're talking about blood volume and you tell, okay, your cardiovascular system, right, also works along with your renal system, then there has to be a mechanism, right? There has to be a mechanism in your kidney that senses a volume drop, similarly a volume high, right? Why is it so crucial, Kana? Tell me, why is it so crucial?
Maintain the blood pressure.
Maintenance of blood pressure, thereby, if your blood pressure, right, is normal, what is happening at the other end, at the tissue level? What will be normal? Pardon? Balance. Your pressure is normal. Or the subject is in a state of hypovolemia. If the pressure is normal, what is achieved at the tissue level? You all know the answer. You all know the answer. You just have to think more. You just have to think more. Say, in a case of hypovolemia, the pressure is dropping. What happens to the tissues? Hypoxia, what is it due to? Lack of oxygen means what mechanism is affected? Transfusion. Some other fusion. One other fusion. Yes, onliners, can you all answer? It's perfusion. Spot on. What happened to you? Thought block, huh? Monday morning brain fog. That's okay. That's okay. Any mistakes doable here in my class, it'll be corrected. Shall we try out this activity? Shall we? Okay. Okay. What is define homeostasis? You all know very well. Time and on this question has been asked. Yes, one of you all. Yes, one of you all. Define homeostasis. Simple. Simple answer. Give me a simple answer. Fast. We have to go through the whole module. Yes.
Balance of external and internal environment.
Very good. So thereby maintaining the internal environment or constancy. Right? Status quo remains the same. Right? There can be balancing. But ultimately, what do you achieve? A state of constancy. Internal environment constancy. Okay. Now, you already told me about its significance. Now, with this diagram that is present here, can someone name? Dakshini, would you want to try? It's so nice. It's so schematic and beautiful. You do this diagram, I don't think you'll have any issues later, man. Of course, the intricate details you have to go through. Yes? Yes, come on, onliners. Give a try. I basically want you to do this activity in my presence. That's why I'm asking you. Come on, come on. Yes, you, son, your name, please. Arumugam. Arumugam, try Arumugam. Just name. What? Okay. To the right side, there's something like a cup and a tube. What is that? Yes, what is it? What is it? Somebody's okay. The renal part, right? The opposite one, what does it resemble? Looks like a, what is this? Alveoli. Beautiful. Okay, then the other one. What is that orange thing there? Okay, so what is on top? The alimentary? Okay, then what do you see below? See my cursor moving? Can you see my cursor moving? What is this? Done? Just remember this picture, everything else will fall in line. You understand the purpose of the activity here? Right? Okay. These are all very simple questions. Very, very simple question. I wish I had this module when I did my physiology. We didn't. We didn't. You're blessed, guys. You're blessed. Okay. Using figure 1.1 as a guide, explain the involvement of the organ systems. Okay, you just named them. And we also discussed about it before. List down the internal environment parameters regulated. Come on, here is a beautiful question. Onliners, come on, give a try. List down the internal environment parameters regulated via the respiratory system. What are the internal environment parameters that are maintained? Come on. Through the respiratory system. Simple, you just have to think. You've already done. You also mentioned the condition now. pH, okay, to a certain degree, yes. Then?
Carbon dioxide.
Carbon dioxide, very good, very good. Yes, when you are saying carbon dioxide, what is the other one, Kada? Right? Okay. What else? Anything else? So now you know what are the internal parameters, the vital ones, the important ones, right? So can you go to the next system, the cardiovascular system? We just spoke. Blood pressure, then blood volume, then anything else? Anything else? Yes? Yes? Anything else? Think of? You mentioned the most important ones. Then urinary system. Okay. Yes, onliners? Onliners? Yes? What are the internal environment parameters maintained, regulated by your urinary system? We just spoke. Come on. Please. Onliners. Yes. Please involve. Electrolytes mentioned. Name them. What the most important one? Sodium. Then potassium. Chlorides. Then chloride. Then what's the other important thing? Okay. Yes. Then? Yes. What else? Yes. Yes. Fluid, body fluid compartments. Yes. Yes. Someone is answering. Come on. You may be wrong. That's okay. You can be wrong. You'll be corrected. But I want you to participate.
Calcium.
Calcium. Very important. Right? Yes. Any other mineral you can think of? Very important. by kidney?
By carbon.
By carbs, yes. Yes, okay. What is the other mineral that you can think of? Very important in cellular reactions. Got it. I gave you a clue. I gave you a clue. Right, guys? So now can you? Yes, all these points will come into your mind. And you know, it will be so interesting to see that our subsequent modules will be dealing with each one of them. Right? With the processes. Okay. Then how the kidney regulates. Most important, what did you all miss? Water. Don't you think water main regulation is important? Yes, you're talking about electrolytes. You're mentioning so many things. Water. And all that is dissolved, that it contributes to your osmolarity. Right? Contributes to your osmolarity. Okay. So we are done here. Let us go through. Okay, so you know now that many of the chemical and physical parameters in the internal environment. Physical parameters, your blood pressure, your blood volume, chemical parameters, all that you mentioned now. All this is regulated by your kidney. Now, you should know that subsequent topics are arranged in such a way that whatever we discussed till now is handled independently in each module. So it requires you not to have a bird's eye view, but to know the intricacies, right? And in order to understand that, structurally, you must be able to relate. Histologically, you must be able to relate to one function, right? Histology. First, you have to look at the gross anatomy of the kidney, its position, ureters, bladder. Done? Then go to the kidney, right? A cut section. And in the cut section, you will see the cortex, medulla, and the arrangement of the pyramids. You see the calyces. Then you see the ureter. Now, what you will do is portion by portion, we will see in the subsequent lecture, you will have to magnify to understand the beauty of the functional anatomy. You will also see that there are two. What is the functional unit of kidney, Kana? Beautiful, nephron. Do you, is there just one kind of, set of nephrons?
No.
Why? If you say no, reason. If you say yes, again reason. Why? Come on, tell me. Why? Why? Why do you think? Are there two sets of nephrons? If so, what? Enema? Yes, yes, dear. Huh? Millions of nephrons are there. Accepted. Accepted. Are they are in the same locale?
No.
Then one in cortex. Okay. The other in? Will you say medulla? Somebody said. Somebody said. Come on, come on. Juxtamedullary. What do we mean by the term juxta? What do we mean? Juxtapositioned. Medicos. Just beside. This is one term the medicos can, really feel. It's ours. Juxta, right? So now you have a very broad view. Yes or no? You have a very broad view. Shall we look at the pictures? Shall we look at the pictures? Okay. So see, they have clearly stated, the module states, please be familiar with the following terms. Now this portion, I want you to highlight in your copy that you will go and read. Whenever I say highlight, please highlight that portion, right? All of you will have highlighters with you, those of you who have hard copies. Those of you with soft copy, please highlight it. I want you all to sit and learn. Okay, I want you all to sit and learn. Unless you know this further, when Professor Hamdan is discussing other things, you will not be able to follow. And there are so many vital, important aspects as a medico, as a doctor. Remember, tomorrow, all of y'all will be serving as a houseman, and you're the first point of contact, right? When the patient comes. Unless you have these basic principles in mind, you will be not able to turn a single stone a paper there. You cannot wait for the postgraduate to run and come. Initial diagnosis, dehydration, water intoxication. Okay, what does serum electrolytes mean to you? It shouldn't mean Greek and Latin to you then. Right? All this you people will have to know. So wherever I say highlight, please highlight. Right now, I want you to focus on this picture. Look at this lovely picture. Okay, can someone explain, onliners? Can you explain the first picture? A, just an outline, just an outline. Just tell me. Everything is there. But I want you to observe. I want you to turn your attention to the picture, its location, the wonderful colors that are there, and you must reinforce this in your memory. In your memory. Your further reading and learning is based on this. Right? Can one of you all, onliners, would you want to try, Kanna? Yes, fast. Onliners, come on.
Doctor, is it the structures that are involved with the urinary system?
Be sure. Why do you say is it? What do you see there? Come on, describe. The first picture, A. Yes. What do we see here? What do we see here? We have lots to cover. What do we see here?
Kidney, doctor.
Yes. Then what comes out of the pair of kidneys? What comes out?
Urethra, doctor.
Yes, leading to? Very
The
good.
bladder.
Yes, from there, what do you see? Going down? Going down? Yes, what do you see?
It's a cross-section of the kidney, doctor.
No, Kanna, I'm talking about picture A. From the bladder. Yes, the others can answer. The others can answer. Yes, what is it? Urethra. Very good. Okay, now we go to section B. What is it as in, what is it? What is B? Cross section of the kidney. You want me to enlarge? Are you looking at the screen? Yeah. Okay. So your personal gadgets, right? If you want to look at the screen, I'll enlarge it for you. But I'm afraid that it would blur. Better? Better? Yeah. Okay. Now we are at in the cross section of the kidney. Now, what are two things? The first thing to strike your mind: artery and a vein, named according to where it is. So very simple, right? What is it? What is it named as? Very good, very good. Right? So you see the renal artery. Okay, then you see the division of the renal artery, and then its subdivision. Now comment on the kidney. Comment on the kidney. Someone? Yes, please. Outer cortex and inner medulla. Okay, Abhi, can you walk up to the board and show us? Walk up to the screen. Come. Outer cortex, okay, and inner medulla. Very good, very good. Okay, so this is the gross structure. Now, as you magnify, you will see the specialized architecture, which is very different from one to other, right? So if you say you are enlarging at one particular point, you see a particular nephron, you know you are at the cortex, right? So immediately it must strike you that there are two sets of nephron with two different locales, but you're looking at the cortex. Similarly, you can also be looking at the which portion? One is the cortex where the nephrons are present. Well, which is the other portion? Yes. Do you say medulla? Yes. Every time you say juxtamedullary. Okay. Now comment on this picture. The amplifier, very beautiful picture. Look at the colors in which it is given to you. Very easy to remember. Yes. Anyone else wants to volunteer? Onliners, come on. Come on. Onliners. Okay. You see my cursor. Which nephron is this? Yes, yes, come on. Huh? Why is there so much of doubt? Why is there so much of doubt? Come on, give me an affirmative answer, a confident answer. Yes, yes. Now look at my cursor here. This one refers to? Okay, okay. Now let's concentrate just on the cortical nephron. Okay, do you see a network here and a cup-like thing? What is it called, Kanna? Yes, right. From there you see, right? Can you describe it now? All the names are there. You just have to trace it and tell me. Right. Now, okay, I move my cursor. What is this portion, Kanna? What is this portion called? This is loop of Henle. Okay, this one? This one? What is this called? What is this called? Yes? Proximal convoluted tubule. Proximal to what? If there is a proximal, there has to be a distal. Proximal to what? Distal to what? Okay, okay. Does it differ in thickness? Yes. Yes. So can we rename it?
Thick ascending.
Okay, very good. Then, if there is a thick, there has to be? Where is the thin? You see here, right? Then you have the loop of Henle. Okay, we are done. You know something about this. Accepted. Let's go to this one, the other set. What is the most striking thing here? Yes, what is the most striking thing here? That is fairly different from what you see in the other set of nephrons, other nephron. Come on, come on, think, because this has a relation to what you are going to read. Yes, onliners, anybody wants to answer? Come on, come on.
Doctor, it's the vasa recta.
Beautiful, vasa recta. Look at the picture again. Compare, right? There is a significance to it, right? Its presence is necessitated by physiological factors and they subserve a physiological function. Got it? So in which set of nephrons do you see the vasa recta? Very good. So you are now, I won't say thorough, but you've learned the picture, yes or no? Yes. Functional anatomy to a certain extent, the gross and the schematic diagram. We haven't gone into histology as yet. Okay, so these are the kidney and the related structures. Please try to answer these questions that are here related to the gross anatomy of the urinary system, right? So please read up. Now look at this one, terminology for tubular segments. Remember, you will not be able to write the expanded form always. It's time consuming. So whatever is given in the module, the universally accepted abbreviations, which you are supposed to follow, right? So when we say something, when I say DCT, it must strike in your mind that it is the what? When I say TAL, why thin ascending tube also is thin ascending thing also is TAL only? Lim? How would you differentiate? See, sir has already given everything is served in a platter to you, man. All that I have to do is take the horse to the pond, but drinking, the horse has to do. Got it? I'm taking, the pond is there with all its richness, with all its nutrition, academic nutrition. Okay, right. So now look at this picture. Closer, no colors except there's a slight shading done. Is this picture clear to you? Very clear, right? Schematic, absolutely clear. Now my suggestion is, if you want to look at how it looks in reality, go find atlases, right, which have actual photographs there, right? So you all can go and see. Thereby you will understand how it looks. These are all schematic, but see, as a UG, it's more important that you get used to these pictures first, right? And for knowledge sake, and you know that that spark that is there within you, please go and see. Okay. Now, do you understand this? Right? Do you understand any doubts here? Do you see the collecting tubule here? Okay, what do you think it connects to? Wild or mild guesses? Simple. If I tell you, you all will laugh. Medulla? Where the other end connects, Kanna? Leave alone this part. Leave alone the renal part. Where does it connect to? The kidney part. It's as simple. Okay. So nephron as the functional unit in kidney, right? Now functions of different set of segments of nephron. This, let me tell you, is indispensable. Okay. Normally what we do is we will ask the student to create this tabular column. It is beautifully given to you here. All you have to do is just read it. I'm not going into the details. Look at the tabular column. It talks about the segments, the description and general functions of the segment, characteristics in cortical nephron, characteristics in juxtamedullary nephron. Right? So it talks about the segment and it talks about the two nephrons. So beautifully differentiated. All you have to do is have a paper beside you, make a schematic diagram of your cortical nephron, make a schematic diagram of your juxtamedullary. Your picture can be ugly, but as far as you all can understand, it's okay. I don't need a Leonardo da Vinci there. I only want to see a medico there. Okay. So keep that, then follow this. I don't think it's so clearly given in any other textbook. See, you are welcome to read the other textbooks, whatever sir has given as references. These are standard, universally accepted references. But my suggestion will be is to go through this first, right? Do this. And when you do this, you will be able to answer any question, right? I'm not talking about the intricacies in the functions, but you must know where it is happening. If you know where it is happening, you must know the locale. Is it cortical or juxtamedullary? If it is cortical, then how it acts. In juxtamedullary, what is the difference? Right? You have different segments. Now, come on, name the segments of the nephron. It is there in front of you. It's okay even if you see it. It's like an open book exam. Yes, students, onliners, can you name the segments of the nephron? Come on, try please. What is the first one you will talk? Go, follow a pattern. Look at your module. Come on. It's like an open. Come on, son. Okay, first is what? Your renal corpuscle or? Yes. Followed by? Imagine, proximal convoluted tubule. Then straight. Then thick. Yes, thin. Yes. Followed by? Then collecting ducts. Now, can someone say it from your memory? Just all of them, all the segments of the nephron. Yes. Yes. Very good. Renal corpuscle first, then okay, we are literally combing the module, right? But the idea is you may not get so much of time to do all these things in the subsequent modules because they are all based on this. Right away, we will be talking about the segments of the nephron. Unless you know it, you must bring to mind the picture. See, you must always have that picture in your mind of a nephron. It can be juxtamedullary, it can be cortical. What am I talking about? When I say filtration, immediately where should your mind go? You must go to a location where the filtration is actually happening. When I say reabsorption, you must know what we are talking about. When I say secretion, when I say excretion, immediately connect to the functional anatomy portion. You are done. You are done already. You just have to go through again and again only to understand the processes. Then comes your clinical correlation or your applied physiology, right? Your applied physiology. Isn't it easy? Right? Okay. So this is another picture, right? I leave it for you all to read. Okay. What do you think in this picture? Do you see shaded gray portions? What does it refer to, Ma? What does it refer to? Yes, various regions. Okay. The color variation, what does it mean? The color variation. Because now we are going into one other aspect. So we were now talking about the structure, right? What does the gray color variation mean? Vascularity. See? Concentration of what? And what is that term, physical term? Osmolarity. You saw the structure. Now we are looking at osmolarity. Isn't it an important function of your renal system? Right? What were we? Regulation of water, regulation of osmolarity, regulation of salts. Here we are looking at osmolarity. Right. Okay. We are looking at osmolarity. And now comes the difference between your cortical and juxtamedullary nephron. You have to, this is a must know section. Okay. See, not very important. Nice to know. Important, has some value. Good to know. Indispensable, you can't do without. Must know. As medicos, must know, you cannot do away with. Okay. Look at this. So, in summary, does someone want to summarize the onliners? Do you want to summarize? 1 hour gone, we have more to cover. Of course, very detailed portions. The most important we'll be discussing in the class, but I want you to have a full idea of the module. Okay, I may rush further. Okay, does someone want to summarize whatever we've learned till now? What did we talk about first? Yes. Yes, very good. Significance. Then the functional anatomy, beautiful. Then very good. Excellent, excellent, excellent. 3 processes. Then other systems involved. The interplay with the other systems. Yes. Can you recapitulate that picture where you had to name? Very much reproducible. You can draw it, right? You can do it. Absolutely doable. Then, what else? The structure of the nephrons. And what did you learn in that? The types. Very good. Okay. Dictated by its location, right? Then I gave, there was a beautiful column presented by Prof. A beautiful tabular column. The segments. Yes, very good, very good. Done. Okay. So the first half we have recapitulated. I think it will mean more to you when you get back and read. Yes. Okay. Now we go into the histology, right? Please dedicate time to look at this, because without this histological pattern, right? Whatever physiological attributes that you are looking at in the urinary system is not achievable. Do you get me, students? Right? Okay. So let us look at this. You want me to enlarge it further, but all of you have the soft copy or the hard copy, right? Okay, onliners. Onliners, you here? Do you appreciate the difference in the histological structure according to the segment? Do you appreciate the difference? Yes or no? So beautifully done. Look at this picture. Look at this picture. Do you appreciate the histological difference? Yes or no? Please, I want you all to. Yes, you do see, right? You look at the arrows, look at the segments, and also correlate with the what? What is depicted in gray color? Shades. Areas, right? Cortex, outer medulla, and inner medulla. Yes, son, you look a little disturbed. Can I help you? Yeah, you come. You didn't understand any portion? You want me to say again? Which one? You understand. Okay, in case you have a doubt, stop me. Right? Any of you, even the onliners, in case you have a doubt, okay, please stop me. Right? So try answering these questions. I'm not discussing the questions here. Go back, right? Sit down. There is a purpose for which these questions are here. Nothing is included in this module without a purpose. You must go as a student, go that extra length, right? Pick up whatever information. Definitely within 2 hours, all the information cannot be given to you, right? We can speak for hours for each module, but that is not our intention. Is we work together, right? We work together. So I want you to try answering these questions. Answer these questions, then come back again, refer, see if you are right or wrong. It gives you a fair assessment of what knowledge you've acquired. Do again. Strengthen. Do again till you hit, till you are convinced, right? Till you are convinced that you are well read. Okay, let's go. Similarly, histology of the nephrons, you see parts of the tubule, type of epithelium, the special features and functional significance, right? Now we go to the ureter, urinary bladder and urethra. Please read up the anatomy. Very simple, yet very, very important. Not complicated. You needn't have to break your head. And just go through the summary. You will understand why that particular cell or patterning or the architecture, why that particular cell is designed, for what reason. Look at this. The fenestrated characteristic of the glomerular endothelial cell helps filtration of plasma into the Bowman's capsule. Every structure has a function, but you must read it, okay? This is a beautiful summary, everything put in simple terms, understandable for a UG. Got it? Then go through the renal blood supply. I am not going to discuss on this. I want you to sit and read, okay? Just imagine if only you didn't have your renal system. Can you manage? You can't. Then don't you think you have to read it up? Okay. Right, again, there's a small activity. So nice, so nice. Look at that. Okay, try to answer all these questions. And remember, your module has answers for all these questions. Right, only the horse has to drink. Everything is there. Okay, again, an activity. Okay, and then about the renal artery supplies. Okay, and how it does. When it does, you must know how it is regulated. That is very important, okay, how it is regulated. Why? In summary, renal blood flow is very important consideration when we discuss kidney function. So you must know everything about renal blood flow. I have seen students neglecting that portion. See, even in regional circulation, you all are taught, yes or no. How many of you all read? Be honest and genuine. Be good children, huh? How many of you all? You all will read coronary blood supply. Am I right? Blood supply of the heart, coronary system, cerebral circulation. All that you all will read. Tell how many of you all did renal. You all must read even this, man. That is why again we are revisiting that portion in urinary system. Actually, it belongs to this, but we do read a little in regional. Okay. Nerve supply. What are the principal? What could be the nerve supply? Okay, what are the broad divisions? Come on, tell me. Afferent and efferent, okay. Then, yes, beautiful. Autonomic nervous system, okay. If you're talking about autonomic nervous system, what are you actually, how would you divide it? Okay, then what is the outflow? What is the outflow? Come on, what is the outflow? Oddliners, tell me, what are the two outflows?
Doctor, one is the thoracolumbar outflow.
Very good, thoracolumbar. What's your name, Karna?
No, Wakar.
Pardon, dear?
Wakar.
Wakar.
Yeah.
Okay, Wakar, I owe you a chocolate. There's a child in everyone, right? I'm just trying to reach out to that little kid there. Okay? The child in you. Yes, yes. So we were talking about, she said thoracolumbar. Automatically, the other one? Cranial? Okay, right? Now you must know how the sympathetic fibers, how they enter the kidney and supply. Similarly, it's contemporary. What is the other one? Sympathetic and? Okay. Look at this picture. Innovation. What more do you want, man? Everything is there. What more do you want? There's nothing that you have to run around. Of course, that extra reading, you want to see the atlases if you want to learn more. Tortora is there. Okay, you want to learn something extra or you want to just clarify yourself, the other reference books are there. Right, look at this picture. Wow. Then there is an activity on the renal nerves. Now, why are you telling me the physiological importance here? Why do we have to learn this? What is the relationship between the nerve supply and the function of the kidney? See, that is the principle here. That is why we are asking you to read. Why? Yes, onliners, can you answer? Try it, Anna. Why are you hesitating? Make mistakes. Absolutely doable in my class. Go refer your module. Read up again. Reinforce your knowledge. Come on. Answer. Just see, this is my first session with you. You must get used to my way of handling. Yes? Reflexes. Further. No, I'm talking more about the functions of the kidney as such. How you have not arrived at that point yet. Pardon? Regulate the absorption. Regulate the absorption. Further. Why afferent and efferent has to be regulated? Why? Think of the functions of the kidney. Think how it has an interplay with the other systems. What influence can this have? Connect everything. Put all the dots. You all know the dots. It's just that you all are not connecting it. Come on.
Because basically how the urinary system works is basically on changes in parameters.
Changes in
parameters, in the body parameters. So basically,
you said body parameters. What are those body parameters exactly this has an influence on? You're right, son. You're right. Can I transport? Yes,
Doctor,
yes, dear.
What about
Yes.
the blood pressure?
Yes. Okay, dear. So do you think
It has a direct effect on the blood pressure by regulating the volume.
How does it bring about? I'm trying to get the word from you. How does it bring about? You're right. Just furthermore. Yes. Now this will tell you why it is important to learn the nerve supply.
Because there's like a barrier, so there won't be any transmission of
Do you think the kidney responds?
Not really. It doesn't. Well, how do I explain it?
Okay, it's good. You start thinking now, right? You start thinking. Go back and read. Right? Subsequent lectures, you will know what is actually happening. Just start thinking. I'm happy that I have at least triggered your thinking here. You are attempting at something. Yes, just go read up. You will see pieces of information falling together. You will get a picture, right? Okay. Now, innervation of the bladder. Look at that. There is an activity. I want you to especially do this activity. And will you tell us in the next class? I'll give you just 3 minutes, sir. 2 to 3 minutes. I don't want you to give a lecture on that. Everybody will benefit, right? Your name, dear? After. I know your name. I just forgot. Poor old lady, la. So in summary, the kidney, is innervated mainly by the sympathetic nerve to the afferent and efferent arterioles and the proximal and distal tubules. So the main thing is the functional unit of the kidney from whatever you've learned is your nephron, the location of the nephron, the difference in osmolarity of the cortex, medulla, outer and inner, right? And then you know that it has a nerve supply, it has a blood supply, and you know its importance, right? Okay. Now let us look at the general functions of the kidney. Wow, look at this. Now this sums it all. Renal functions. So come on, name. Onliners, can you name? It's right in front of you. Can you name, please? What are the general renal functions, dear? Yes?
Regulatory, excretory,
Endocrine?
metabolic.
Metabolic, right? So it is a rene. What is it? It's rene. R stands for? E stands for? Another E stands for? M stands for? And then you will forget the mnemonic itself. Yes or no? It happens, right? Yeah, I was a medico at a time. Yeah, yeah, I know. Then you will keep thinking, oh, there was one mnemonic. What is a mnemonic? Right? Very easy. Then from here, you look at how it does. Regulatory. What does it do? Here's one of y'all from here. Here's one of y'all from here. It's good that all are participating today. I'm very happy. Armugam. What are the regulatory functions, Kanna? I want you to read this again and again, because subsequently we are going to see the regulatory functions of kidney in detail. Fine? What are the excretory functions? What is his name, Raja? What's his name? Yes, Kanna. Sarvesh. Sarvesh, you can tell me? Excretory? Okay. Then endocrine? Yes, one of y'all? Someone from this side who has a Vaishnavi?
Vitamin D, renin, prostata.
What are all these? They come under endocrine, so what should they be? This you won't answer. Hormones. Metabolic? Metabolic, Janani? Repeat. You will see how it works, right? Later. So these are the general renal functions. Now coming to the excretory function. What do you mean by excretion actually? This is all, I'm just giving you an outline, right? What are the excretory functions? What do you mean by excretion? Basically, you must know the difference. Filtration, reabsorption, secretion, excretion, right? What do you mean by excreting something? Removal. Should it necessarily be a waste? Normal substances are also removed. What is required?
Excess.
Excess. That is a term that qualifies it. Excess. Okay. Now you are looking at certain substances here. Urea, creatinine, uric acid and bilirubin. Okay. Now you must also know that these can have a specific function. So that is why it's importantly mentioned here. Look at urea as an indicator for renal function. It's excretion to tell that your kidneys are functioning normally. I will be next doing evaluation of kidney functions. We will be looking at all whatever is mentioned here. Creatinine from metabolism of muscle creatine is used as a gold standard indicator for renal function. Tomorrow when you become houseman, what will you ask for? Hemogram, blood urea, blood sugar, creatinine. That will be standard. Like a robot you will write, but you must know why you are writing. Okay. It's good that you're writing like a robot. I appreciate your memory, but what to do with that memory when it cannot substantiate itself, right? You should know why. Okay. Then uric acid. Have you heard of gouty arthritis?
Yes.
What happens? Crystals deposited where? In joints, right? Then bilirubin. Bilirubin, very important. Jaundice. What it does to the urine? What does bilirubin do to the urine? What does it give? Its color. So while you're doing the analysis, you will know that all these things, just by looking at urine, you will be able to fairly arrive. You confirm, but then you will fairly arrive. Okay. Now excretion is okay. Now there's a nice note here which sir has attached. Carbon dioxide is an important waste product removed by the body from the body via your respiratory system. You all know very well. Already you all are pundits of respiratory system. Yes? Yes, Afkar?
Yes.
Okay, yes, I like that confidence. Okay. Now, excretion of bioactive substances. So you're talking about hormones, many foreign substances, right? So see, anything that goes through the kidney has to be water soluble. And remember, most of the medications that we take, most of the substances our body is exposed to, most of it which we consume, it can be even toxic. While you're consuming a vegetable, you would be also consuming the fertilizer that was sprayed on it. We wash it, but still it has entered. The cooking process, yes, right? The cooking process destroys it, but still there can be residues there. So you have to think about that, okay? And read this note below, okay? So we go to the regulatory functions. Oh, I like this. Regulation of water and electrolyte balance. Regulation of arterial blood pressure. Regulation of blood pH. Conserving nutrients by limiting their loss in urine. So limitation. Okay, does normally glucose appear in urine? No. When does it appear? Diabetes. Okay, some renal pathology. So if you find sugar in urine, glucose in urine, is it normal or abnormal? Say your urine is concentrated, does it indicate an abnormality? Why? Afkar is on a camel. He's in a desert. What kind of urine you would be passing, Afkar? You forgot your water bottle or you finished that whole water bottle?
I have a very...
Yes, come on. Concentrated, right? Yes, somebody told me, one beautiful slim lady on TV said, drink 7 liters of water. I said, why 7 liters of water? I'll drink 14 liters of water. I'm passing what kind of urine? At the same time, I can go into a different pathological condition. What is it called? What I'm drinking more? Water intoxication. Even this is handled by your kidney, right? Water of life, water for life. Too much of anything is good for nothing. Too much of anything is good for nothing. Okay. So look at how beautifully your kidney is doing all its regulatory functions. Wow. Water and electrolyte, right? Water and electrolyte. Then your arterial blood pressure. When you go into the clinical side, you will know what happens with electrolyte disturbance. Right? Hypokalemia, hyperkalemia. Hyponatremia, hypernatremia. All these things you will have to handle. So better study well now. Okay. Then regulation of arterial blood pressure. I love this portion. You will love it as a physician. If you read this, you will know what drug to choose to produce what kind of effect. What sort of a patient are you handling? Youngster, geriatric, middle age. What will you use? Diabetes plus or minus. Proteinemia plus or minus. Hypoproteinemia, proteinuria, you must be able to choose. Okay. Complicating. What are the diseases? Your choice. All. Unless you know this regulation of arterial blood pressure, as physicians, even as housemen, you will not know. Okay. Regulation of blood pH, conserving nutrients by limiting their loss in urine, and then endocrine functions. I'm sure you guys would like this. Yes, yes. Pardon? Yes, yes, please, please. I will give you permission for this at any stage. Okay. Can you now? We are not going through this. You tell me on your own. Come on, participate. Onliners, tell me what are the hormones? Erythropoietin, then renin. Have you heard of one renin? Where? Are there two renins in the body? Yes, where? Huh? You just tell me which system you read the other renin. GIT. Okay, what else? What else? Then what else? Prostaglandins, right? Right? Very interesting read. I'm not going to tell you how it's working. You all know very well. Even in hematology, have you read about erythropoietin in hematology? Yes. What is the advantage you have over the women here? You have more hemoglobin than us. Why? So they have more hemoglobin. Sony. Come on, tell me. Come on. Hey, fun apart, guys. Come on, tell me. Tell. Because of their bone mass. Okay. Look at the screen. I'm talking in relation to this. I'm asking you about erythropoietin. Just a small digression from the topic to make it a little, not so boring. Will you read up?
Maybe because men how they're built, because they're built and
what gives you that build?
The bones, the muscles.
What gives your muscles has that boost from what?
The testosterone.
Now tell me what it has, how it has an effect. Will you? I'm not giving Afghar this, assignment. Come on, girls. It's a challenge. It's a fight between you and Asghar. Okay. Kribashini will find out and she'll let us know. Okay? Right. Now, what are the metabolic functions? We already saw. Where's our friend? Oh, no, Janani. Janani. What are the functions, Janani? You told us? What? Okay. Then? Okay. Pardon? Parathyroid, PTH, metabolism. Okay. Now, is it important to know this? It has an interaction. Refis. It's very important. Okay, you just can't learn the terms and leave it. Say you have to think about the side effect of sulfonylureas. Right? What are sulfonylureas? In which disease is it used? Endocrine. Yes. Endocrine done? Diabetes mellitus taught? What? Okay. So read the class sentence under insulin metabolism. Decrease and the drug. Okay, that is the last sentence. If you want to know its importance, you have to read that entire paragraph. And remember, see, when something like this is told to you, you can have clinical scenarios related to this, and you can be asked on the renal function. Right? Now this becomes a fertile field when it gives a clinical input there. It becomes a fertile field for your SAQs. Your PBLs are based on this. Your case studies are based on this. Your clinical scenarios are based on this. So kindly don't ignore. If you read this, you will be able to crack any question. See, we are not going to ask you PG questions here. Sir has beautifully explained here in the module. It's only that you will have to read, conceptualize, understand the principle. Then you will be able to tackle your clinical scenarios. Remember, we are asking you only the physiological principle. It is not your differential diagnosis or management here. That next level. That is next level. This is the first round. Got it? So general functions of the kidney, try answering these questions. Then the body fluids, you see the compartments there, right? Now this is one very, very important activity. Now I am stressing again and again on these activities because don't think it will appear only in the urinary system. When you are talking about body fluids, it can be the compartments, it can be the distribution, it can be the regulation by your kidneys, right? You are talking about water at one end. When you're talking about then special conditions. Now, two things that can be altered. What are the two things in two main compartments in the body fluids? Come on, come on. It is there, Raja. Extracellular and intracellular, right? Unless you know how the kidney is regulating it, you will not know, right? And at which segments it happens, okay? And as you read further, you will also know how osmolar concentrations can alter, how water can be altered, how it can, what is the difference between dehydration? What do we mean by isotonic, isoosmotic, hypoosmotic, hyperosmotic? Unless you have a knowledge about that, how are you going to put IV fluids? There are a variety. Normal saline, dextrose normal saline, 5% dextrose, 10% dextrose. You must know what effect it has in each compartment, how your kidney is going to regulate that. Your kidney can be absolutely normal, but your dehydration can happen so many ways. A road traffic accident, hemorrhage, diarrhea, vomiting, exposure, right? So look at the body fluid compartments, right? Look at this. What happens in the ICF? What happens in the ICF? What happens in the ECF? Where do chemical reactions occur? ICF. Why do you say ICF? Because the seat of chemical reactions is within the... right? Are we going deeper now? Okay. So as you go, look at this picture. Look at this picture. Wow, I like this picture. Body fluid distribution. Can one of y'all, okay, onliners, can I have someone to try to try to explain this picture? I can't use a term breaking because breaking normally I do with a graph. What are the two main compartments, onliners? You all take a deep breath till then. Yes? What are the two main compartments that we are seeing? Kanna, come on.
Intracellular and extracellular.
Okay, okay. Then what is that orange shades of peach, dark light peach? What is that portion in extracellular?
Blood plasma. Blood plasma.
Okay, the blue one, the blue one.
Interstitial fluid.
The green?
Intracellular fluid.
Is there a transfer from all the compartments?
Yes.
Between all the, not from, I'm sorry, between all the compartments?
Yes.
What is a transcellular fluid, Kana? Would somebody else want to try? What is a transcellular fluid? And what is the interstitial fluid? So apart from ECF, ICF, what all you say, there are some more compartments also, right? What are they? Recapitulate, think, scrape your memory. Come on. Come on, come on. I know only his name, that's why I'm calling out. What's your name next time I catch the two? What's your name? Joshua. Josh. Yes. So you must know what are transcellular fluids, right? They all participate here. They all participate here. Such a nice picture. Look at the values of sodium, potassium, chloride, protein, osmolality. Simply, I'm not showing you this picture. It has a specific purpose. It has the values, and these numerical values, apart from knowing the actual value, there are certain areas where you have to just memorize. Okay. Now you must understand, you must know what process leads to that difference. Look at sodium in ICF. Look at sodium in ECF. Do you appreciate a difference? Yeah. What is it? What is it? Potassium?
Higher in intracellular and lower in extracellular.
Okay, chloride?
Chloride is higher in extracellular and lower in intracellular.
What about osmolality, Kana?
The same.
It's the same. Now, can you tell me, sodium is more outside. Potassium is more inside. Okay, then you're looking at protein and osmolality. Does a kidney have to do something with this? Yes. What does it do? What does it do? Reabsorption. Do you think something else will also be involved along with the kidney? Pumps, okay. Something else also. What is the one function of kidney? What is one other function? No, ream. What is one? Second D. Now tell me. Connect these points. Connect these points and tell me. Is there any connection with some endocrine, some
hormones, muscle.
Yes, yes. What's the other one? Yes. Yes, why? You can tell, man. Make a mistake, that's okay. But learn the right thing, right? Okay. So you are seeing that, and look at the plasma, right? So when you look at the blood plasma, you're looking at the interstitial fluid, you're looking at the intracellular fluid, right? So all these things are happening here. But remember, at various segments of the kidney, right, you can have different kinds of pumps. You can have different kinds of pumps acting at different site also, right? One can be at the apical. One can be at the basolateral. Between the cells, there can be diffusion, right? So various transporters that are acting. Okay, so when you look at this picture, apart from looking at the different compartments, look at the normal values, think of your nephron, think of the various segments, think what mechanisms are being operational there. Got it? Easy. You think renal system is tough? Isn't it easy? Not yet. You got me? Not yet. Maybe after 2-3 classes. Okay, now we are done with body fluid. Okay. Then balance of chemical substances. We already saw, right? Now how we gain fluids, the intake and how we lose. Output is different. Loss of fluid is different. In respiration, we lose. Menstrual flow, we lose. Right? So you must know that. Urinary output is different, but like insensible loss. You actually don't feel that you are losing, but you are actually losing. Okay? Net gain and net loss. Okay. Then again, there's a beautiful picture to show that. So basic renal processes are here comes, I won't call 3 heroes, not 1 hero, 3 processes. Okay, what are the 3 basic processes? Secretion. Okay, so please remember these 3 processes will be dealt with in detail, but you must prime yourself with knowledge from this module. Okay, what is filtration? Can someone read? Come on, Salini. From through the glomerulus into the nephron tubule. Reabsorption. Betty. Okay. Secretion. Onliners, one of y'all. Onliners, one of y'all. What is tubular secretion?
Movement of unfiltered substance from the blood into the lumen.
Okay, so you will have to know this by heart. Understand and read. Filtration, filtered through the glomerulus into the nephron. Got it? Reabsorption, movement of filtrate from the lumen back into the blood vessel, reabsorbing. What is secretion? Unfiltered substances from the blood into the lumen. Got it? Got it? Yes. Excretion, the final thing, it is given in a nice equation. So if one of the values are substituted and given to you as a problem, if you know this equation, you will do it. Yes or no? Okay. Later we will tell you how to calculate. I'm just telling you. So can someone read this? The equation urinary excretion is equal to? If you read like this, you will not remember. So go back, read again what is filtration, what is reabsorption, what is secretion. Then you do this. Okay. So when one of the variables are not given, the others are given, can you calculate? You can. Now further intricacies in these calculations, you will read further. Okay. See, that is why Prof says here and there that it will be dealt with in the subsequent modules. Okay. Now, principles of renal pathology. What could go wrong? In which part? That gives rise to the disease process. Right? See, he says in general, although only one anatomic component is affected by injury, the function of the other anatomic components could also be impaired. Such an important message in a very simple statement. As doctors, don't ever think that only one damage can exist. Right? See, your blood supply is compromised. Okay? Initially, it can be an injury, can move to ischemia, can move to infarction. And it cannot be just, you can't say only that portion. Surrounding structures also can. The kidney is so tightly well packed in layers cortical, medulla, nephrons there, nephrons here, vasa recta. Okay, so you have to understand that. So you must know, okay, of acute kidney injury like AKI. Now, what can the features be? The compromise of all the functions, main functions. Very simple. When you look at kidney pathology, or for that matter, any organ system, right? When you are looking at the pathology, what do you think will get affected? Basically, the function, right? Now, it depends on the direct functions, the regulatory functions, the mechanism of action, right? Indirect functions may get affected later. But what happens when that one particular faculty is lost? Okay. So what can be the features? Then comes your investigations, and what do you actually see? Certain molecules may rise, some may drop, right? And when you look at the functions of the kidney, the regulatory functions, when that is lost, you know very well the chemical substances that are regulated by the kidney. So when the function is lost, look at that particular chemical substance. Now, why are you looking there, man? Joshua. Okay, that particular chemical can rise. Okay. So if it rises in the urine, concomitantly, it can drop in the blood. Yes or no? Proteinuria along with hypoproteinemia. Right? So that correlation you all must be able to do, and you must know in what specific conditions, pathological conditions. This is all applied physiology. Right? See, look at uremia, hyperkalemia, metabolic acidosis, fluid overload. Now all this has secondary effects. Hyperkalemia, hypokalemia, cardiovascular system. Right? Have you, okay, you have, okay. Uremia, right? When can uremia occur? What is uremia, Kanna, basically? Somebody was talking, regulating that particular from this side. Kalaichilvi, you were the one who answered. Come, tell me, what is uremia?
High levels of urea.
Urea. Okay, what does kidney do to urea normally? Does it regulate or not?
Yes.
It regulates. So you must be able to pick up, say you're picking up uremia, right? You must know how it manifests itself. The manifesto is very important. Okay, just these are all, I would say, good to know. Good to know. Okay. Fluid overload. The basic thing is understand the physiological principle. We are not asking you to treat. We are not asking you for where would flapping tremor occur in uremia. What is the etiology? In renal system, how is it important? Okay, I know it is wrong to ask you what is flapping tremor now. Probably in final year, if I ask you, it makes a sense. So we know. No, don't look at your hand immediately. Okay, now pre-renal, renal and post-renal pathology. Just, without any panic, lightly sit and read. Look at the pre-renal pathology. Look at the intra-renal. What do we mean by pre-renal? Okay, what are those conditions? What could be the etiology? Just without any fuss. Onliners, without any panic, it is beautifully listed here. Just go through it. Okay, just go through it the first time. Now look at the post-renal pathology. Prostatic, right? Disease. It can be malignancy. It can be where can you see it? You can see a calculi in the ureters, right? You can see calculi even in the bladder. You can see the urethra, right? And as it moves on, it causes intense pain. All that Post-renal. What do I mean? What do you see the clinical conditions? Now tell me, what do I mean by post-renal? Very good. When I say intrarenal, look at the conditions. Pyelonephritis, right? Acute chronic, acute tubular necrosis. What are we actually talking about? The location, where? Very good. Now look at the pre-renal. I should have gone from pre-renal, but for a change I came this side. Oh, from this side. Okay, pre-renal, pre-renal. Come on, tell me. Yes, yes. What? Look at the conditions. Look at the conditions. Do you see a difference between renal, post-renal, and pre-renal? Are you able to appreciate the difference? I don't want you to memorize, but I want you to appreciate the difference. Josh, do you? Yes, Sarvesh? Do you? No. No or yes? No. No. Go through the, okay, tell me which part you didn't understand, Sarvesh. Come on. Yes. How to differentiate? Typically, see, look at the kidney first, right? The anatomical structure. Whatever is happening within is? Whatever happening below? Okay, post-renal. Now, when you're talking about post-renal, one relation is the anatomical structures, or it can be any malignancy there, any CA there, okay, causing an obstruction, causing a kink. You know what is kinking? Bending. Kinking, right? Kink. Say a tube is there, you bend the tube and hold it, it's called kinking. Space occupying lesion, this is the tube, there is a tumor here compressing. Got it? Obstruction. This all can happen then. Pre-renal, look at all the other things, they are all pre-renal. Take it like that. Okay, now look at what can be there. Volume depletion. Volume depletion can be anything. It can be your heart failure, right? Your heart is not pumping enough. It can be your blood loss in the that you see in the patient. It can be diarrhea. It can be a road traffic accident. It can be a cerebral hemorrhage, but the blood is lost. The circulating volume is down. The hemodynamics is affected. Is it happening inside the kidney? The site of the pathology outside the kidney. Effects will be there on the kidney, but it is happening outside, right? Then look at hypotension. Look at non-steroidal anti-inflammatory drugs producing an effect. Okay? You can have bilateral renal artery stenosis, cause of hypertension. Okay? That's an incidental finding mostly, right? So when you look at this, you know where the pathology is, but still the etiology, this is the, the etiological factors. Partly etiological factors, partly the pathology also having its effect at different levels in relative to the kidney. Outside, within the kidney, after the kidney. Do you get me, Sarvesh? Yes? I can't see your eyes at all, man. Nice mask, very protective. Okay. Okay, go through this etiology, renal problem and consequence. What can happen? Principles are there. Okay. So, the key concepts that you must be, now the class is almost reaching the end. So, the key concepts, read the key concepts for yourself. Onliners too, right? Read the key concepts. Are you convinced that we have touched all? You have learnt them. You have at least understood. Probably your learning needs one more reading, conceptualization, trying to answer all the questions in the activity, right? So the summary is there, okay? Now, look at the learning outcomes. Do you have a problem with any of them? Afka doesn't have any. Josh? Can I your name again, Raja? Iqbal. Iqbal. Yourself, ma? Your name?
Shamil.
Shamil.
Yes.
Shamil. I must learn your names. Okay, girls. Murugan and Sarvesh. Armugam. Paravala, adu Murugan பேர் தான். Samalification. Sorry. Okay. Come on, onliners. Are you sure? Read the learning outcomes. You want me? Yes, dear?
Okay, doctor, understand.
Understand. Good. Others? Any doubts? The floor is open to questions.
No, doctor, we understand.
You understand. Okay. Okay. Shall we discuss the IRATs are discussed now? Or?
I think that's something on Dr. Hafiz.
Okay, Prof. Hafiz would do it. Okay. So, are we done?
I guess so.
We wait for Prof. Hafiz?
I think he's already meeting unless we have to invite him in.
He's left the meeting, is it?
I'm not sure. Is he there? I don't know.
Yes? Can you just ask him?
Actually, I'll just join the meeting. It's not the meeting. Should we try inviting him in?
You ready with your answers? How does it normally go about, son?
Because so you know he just physiology lecture face to face.
Yes. Onliners? Onliners, any suggestions about the class? See, this is my first class and, you know, I didn't, I want my classes to be applicable and acceptable. So you give me the feedback as to what I'm supposed to do. Yes, Mariam, what do you want me to do? There was a link that was shared, Rajan. Yeah. Okay. Yes, any suggestions, onliners? You can give me a feedback later. You can WhatsApp. If you want me to change, do something extra, whatever. But it will definitely be an interactive session. Are you okay with it, guys? Yes, to keep, you know,
Yes,
to keep you. Okay, Kanna, thank you. Thank you so much. Give me a valuable feedback. Please ask her for the asking. Okay. There could have been some hiccups. I'm very sorry, students. I apologize for the delay in beginning the class. That was a technical, and I'm not a technical geek, man. Let me confess. My son keeps cursing me for that. He says, Amma, you've not learned this. I'm not a technical geek. I always had cute students like you all to help me around. So I didn't bother to learn rather.
picking up this phone. Should I call her?
Can?
Should I?
Because I've. What if sir is busy in something else, dear?
No, that's true.
It has to be done at the end of the class, right?
Usually it is.
Usually, okay.
I didn't.
Tada means no, right? Other is yes. It's there.
Yeah. Though my Malay is bad. I'm not from here, so.
Oh, where are you from?
I'm from Brunei.
Okay.